Features of the 1010 data platform let us take advantage of data ordering and parallel computation. You benefit most from parallel processing when an analytical platform manages user interaction and clusters subresults. This is handled by a process called the accumulator, which assigns tasks to subprocesses. Each user session has one accumulator and multiple subprocesses distributed over a cluster of machines. Subprocesses perform subsets of computation in parallel and return results to the accumulator. The accumulator collects, combines, and returns these results. It also runs computations that can't be done in parallel. Limited data movement also maximizes parallel computing benefits. The best solution minimizes unnecessary copying of huge quantities of data, giving you more time for actionable results. The 1010 data platform does just this. Subprocesses reside on high-performance cluster servers with direct attached storage. The subquery goes to the data and returns only results. When we add 100 million numbers, each subprocess has direct access to a subset of 10 million numbers. Accumulator and subprocess communication is limited to the subquery and the subresults. No data is moved, so each subprocess has the fastest direct access to the data. In subprocesses, data for a table is horizontally partitioned to group sets of records together. These partitions are called segments. Each segment includes a portion of the table records distributed evenly across the computation cluster. To ensure the best possible performance, subprocesses only operate on segments co-located on the same server. A segment should include 8 million records and is the foundational unit for parallelization in 1010 data. Each table is made up of at least one segment, with more segments in larger tables. When a query is run, each segment is assigned to one subprocess. However, a subprocess can be assigned to multiple segments depending on how many are available. Let's revisit our city temperature table. We'll use 4 servers, mirroring each segment twice. Mirroring provides backup if there is a server loss. This is a replication factor of 2, meaning there are 2 copies of the data. Our mirror pairs are A and B, and C and D. Servers A and B get the same data. That's mirroring. Now, let's segment the data. We have 8 records in our table, so we horizontally partition the data set into 4 and 4 records. The first segment, residing on A and B, contains the first 4 records. The second segment, with the next 4 records, is on C and D. To simplify this, we aren't looking at a lot of records here. Remember, the target size for a segment is 8 million records.